The next one is chain rule, and this will start 3:7, Matthew. So if we look at the rule over here, so chain rule has to do with the situation when you have a function inside of another function. So you have the composition of two functions. How do you find the derivative of it? Okay, so the main thing that you do here, if you look at it when it's like this, if you're going to take the derivative with respect to x of f of g of x, so g of x is inside the f function, then what you do is you take the derivative of that f function, multiply that times the derivative of the function on the inside. And that is chain rule. Okay? So notice the notation here. You got the derivative of f of g of x. So you still leave g of x in there with the derivative. Multiply times that, the derivative of whatever that inside function is. Okay? So the main thing with keeping chain rule straight as far as what you do is recognizing an outside function and an inside function. Okay, so you got some big outside function, then you got some other function of x that's inside of it. Okay? And you do the outside and then do the inside. And that's pretty much it. He has a procedure here, and we'll do this for a couple of them, and then we'll just kind of do the chain rule. Okay, but here we identify an outer function f and an inner function g. Okay, we let u be g of x. Then replace g of x with u to express y in terms of u. Calculate the product of the derivative with respect to u times the derivative of u with respect to x. Replace u with g of x, and then you have dy dx. Okay. All right, let's try that. So you've got, this is a composition of functions. Okay, what would the outside big function be here?
Uh, 3x plus 7 10 times.
Okay, so, what would be the inside function then? The inside function would be what? The 3x plus 7. So what would the outside one be then, if that's the inside one? It would be the power of 10. Right? That's outside. The inside's 3x plus 7. So doing it the way he said here that we'll do at the beginning, we'll say, let's let u then be the inside function, 3x plus 7. Okay? So now we will replace 3x plus 7 with u. So now I have y equals u to the 10th power. Okay? Now let's take the derivative of that with respect to u. Okay, so you can do y prime if you want to. I mean, for this though, let's stick to since we're using different variables. So I'm going to say dy du. I'm going to take the derivative with respect to u. So I've got u to the 10th. That's easy. How do I take the derivative of that? All right. Multiply by 10, subtract 1 from 10, the power rule. I get 10 u to the 9th power. Okay? All right, so I do that, and then if I take u here, okay, u equals 3x plus 7, I take the derivative of that with respect to x. What is 3x plus 7? What's the derivative of 3x plus 7? 3. All right, so the derivative of dy dx, which would be this whole thing here, is going to be the derivative of this one, dy du, times du dx. So dy du is 10 u to the 9th. Du dx is 3. So I get 30 u to the 9th power. What was u? 3x plus 7. Put that back in there. 30 times 3x plus 7 to the 9th power. Okay? Now, without writing the u out, what I would do here is so doing it the way that we'll start doing these in just a few minutes. I would look at that and I would say, okay, the outside function is at power of 10. The inside function is the 3x plus 7. So first, take care of the outside function. So how do I take the derivative with the power of 10? I use the power rule. So I would say y prime equals, I'd multiply by 10, and then I subtract 1 from the exponent, I get 9. Okay? So that is the derivative of the outside. Now multiply that times the derivative of the inside. What is the derivative of the 3x plus 7? 3. 30. 3x plus 7 to the 9th. Okay? A little more writing there, but it's the same thing, just kind of doing a substitution and writing it separately there. Okay? So what is the difference in the two? Are they the same thing? Not the same. This one, what is raised to the 5th power? The whole thing sine to the x. Here, what is raised to the 5th power? Just the x. Okay? So, here you might want to rewrite this like this. Okay, because that's the same thing. Okay? Now, you have a composition of functions there, right? So, you have an inside and outside function. What is the outside function, the big outside function on this one? The 5th power, right? So you do that, and then multiply by the derivative of the inside, and you got it. So y prime equals, so I'll multiply by 5. Subtract 1 from the exponent, I get 4. Now I got to multiply by the derivative of the inside. What is the derivative of sine x? Cosine x. Okay, positive, right? So that is my answer. And I would write it like this. I would say sine to the 4th x. That's it. Okay? Questions about that? Now, over here on this one, what would the outside function be on this one? Well, I could rewrite it like this. So looking at it like that, what would be the big outside function on the second one there? Sine. All right, sine's the outside one, and x to the 5th is the inside one. So take the derivative of the outside first. What is the derivative of sine? Positive cosine, right? So cosine x to the 5th, okay? Now I got to multiply that times the derivative of the inside function. The inside function is x to the 5th. What is the derivative of x to the 5th? 5x to the 4th. Power rule, right? So the derivative would be 5x to the 4th times cosine x to the 5th. Okay? Anytime you got a radical in the problem, we want to think of that as a power if we're trying to do derivatives. Okay, right? So first, let's rewrite that with a power. Okay. All right, now, what is the outside function on that one? Power of 1/2. Inside function 7x minus 1, just like the one we did before this one. So take care of the power first with the power rule. So 1/2 times 1 is 1/2. Subtract 1 from the exponent. 1/2 minus 1 is negative 1/2. Okay? So that's the outside. Now the inside function is 7x minus 1. What's the derivative of 7x minus 1? 7. Multiply by 7. There you have it. Okay? Now we don't want to leave a negative exponent in our answer. All right, much. And we could probably rewrite it with the square root. So let's just move that 7x minus 1 of the negative 1/2 to the denominator. So I would have a 7 on the top and then 2 square root 7x minus 1. Okay? Questions about that? Okay, so that's the table that they gave us, all right? So they also told us that h of x is equal to f of g of x, and then p of x is equal to g of f of x. Okay, so use that table of values there to figure out what the derivative at some value is of each of these, okay? So, first, if I want to know what is the derivative of h at 3, okay? So, h, they said, was f of x of g of x, okay? So, g of x is the inside function, f is the outside function, okay? So, at 3, that would be the same thing as taking the derivative of the outside. So that would be the derivative of f at g of 3 times the derivative of the inside function at 3. The inside function is g, so times the derivative of g at 3. Okay, now we can figure out those values from the chart. But any questions about that? That's chain rule. Derivative of the outside function times derivative of the inside. Okay, so what will this equal? All right, well, let's go to our chart here. G at 3, all right, here's when x is 3. What's the g function when x is 3? There's g, it's 1, right? So I can say f prime at 1 times g prime at 3. Now let's get those. All right, so f prime at 1, here is 1. F prime is there, so that value is 5. G prime at 3, there's 3. G prime, 20. 5 times 20, 100. Okay, h prime at 3 will be 100. Questions about that? Let's just do one more of those. Let's say we've got p at 4. Okay. All right. Well, p they're defining as g of f of x. So the derivative of that would be the derivative of the outside times the derivative of the inside. So I would have g prime of f of 4 times the derivative of the inside at 4, which would be f prime. Okay? All right, f at 4. All right, 4 is, when x is 4, we have that. F would be 1. Okay, now let's do these two. G prime at 1. Here is 1. G prime would be 2. F prime at 4. Here's 4. F prime's negative 8. 2 times negative 8. Negative 16. Okay. We have an outside function, an inside function. What is the outside function? Power of 8. Inside function is that x cubed plus 2x plus 7. So the derivative, power rule, 8 times 1 is 8. Subtract 1 from the exponent. Okay. That's the derivative of the outside. Multiply times that the derivative of the inside. Okay, well the inside, you got x cubed plus 2x plus 7. The derivative of x cubed would be 3x squared. Derivative of 2x is 2. That answer should be fine. Okay. Wrote down wrong, but that's okay. I think that answer is correct. So, we'll keep it. All right, any questions about that one? Would be the outside function. Cosine. Inside would be the 5t. All right, so do the outside first. The derivative of cosine is what? Negative sine, okay? Don't leave off the negative. So negative sine 5t, and then multiply by the derivative of the inside. The inside function is 5t, so the derivative of 5t is 5. All right, and so I would write my answer as negative 5 sine 5t. Okay, questions about that one? All right, so just like the last one, the outside function here is secant. The inside function is 3x plus 1. All right, so what is the derivative of secant? Secant times tangent. All right, so when I do the derivative, I'll need to put secant and then put 3x plus 1, leave the same thing inside, tangent 3x plus 1. Okay? So that is the derivative of the outside function. Multiply times that the derivative of the inside function. The inside function is 3x plus 1. Derivative of 3x plus 1 would be what? 3. 3 out in front. There you go. Okay, so the outside function is tangent, correct? Inside is e to the x. So outside first, what is the derivative of tangent? Secant squared. All right, so I have secant squared e to the x. Okay, so that's takes care of the outside. The inside e to the x, what's the derivative of e to the x? E to the x. So multiply times e to the x. There you go. All right, so y prime equals, all right, so the big function, outside function again, would be the function of sine. What is the derivative of sine? Positive cosine. So cosine 4x cubed plus 3x plus 1. That's the derivative of the outside. Inside is 4x cubed plus 3x plus 1. What's the derivative of that? Power rule, 12x squared plus 3, right? I would write the answer with this at the beginning and then the cosine, just to be sure that we're clear on what the angle there. So I would write the answer like this. All right, questions about that? Okay, so outside function here would be what? Power 2/3, inside's 5x plus 1. So power rule first. Multiply by 2/3. Subtract 1 from the exponent. 2/3 minus 1. How much is that? Negative 1/3. Okay. So that is the outside. Okay. Derivative of the inside, 5x plus 1. Derivative would be 5. So multiply it times 5. So I would write the answer. 2 times 5 would be 10 over 3. 5x plus 1 to the positive 1/3 power on the bottom. Okay, so again, anytime you got a radical there, then think of that as a power. So I would rewrite this one first as 2x over 4x minus 3 to the 1/4 power. So I'm going to do that first. And then you can tell easily the outside function is that power of 1/4. The inside is the 2x over 4x minus 3. Okay, now the thing is, we'll make this a little more computation to it, is inside you've got a quotient. So when you take the derivative of the inside, you've got to do the quotient rule. So a little more work, but same concept as before. So I'm going to take 1/4, do the power rule, multiply by a 1/4, and leave inside what's inside there. Subtract 1 from the exponent, I get a negative 3/4. Okay? So that's the derivative of the outside times derivative of the inside. So the inside is a quotient, right? So I've got to take the derivative of it, I've got to do the quotient rule. All right? So quotient rule Start with the bottom. So the bottom times the derivative of the top. So 4x minus 3, derivative of 2x is 2. Minus the top, 2x, times derivative of the bottom, which is 4, over the bottom squared. Okay. See questions about any of that? Now, reduce it. How do we reduce it? Okay. Carefully, you know, I guess. You could reduce it different ways. This one will reduce down pretty well with a little bit of work. A lot of times, I don't know, like I'm not sure how my math lab really wants it a lot of times, but a lot of times they want it in a factored answer. But you definitely should reduce this. So I would do a little bit at a time. So let's see, let's see what I did here. Okay, so you got a negative 3/4 power here on this 2x over 4x minus 3. You can make that into a positive exponent by just flipping the fraction. Because that just, it's like the top is raised to negative 3/4, bottom to negative 3/4. So if you flip it, you get 4x minus 3 on top to a positive 3/4 power, 2x 3/4 on the bottom. So let's do that. So I would have 4x minus 3 to the 3/4 power there. And then on the bottom, I would have a 4, and then I would have 2x to the 3/4 power, and then 4x minus 3 squared, okay? Now this, we'll see what happens to all of that. All right, so if you just take the top over here and reduce it, notice you got 4x times 2 is 8x. Then here you got negative 2x times 4, which is negative 8x. So 8x minus 8x is 0, right? So the x's go away. All you're left with is negative 3 times 2, which is negative 6. Since you got one negative, the fraction's a negative. I'll look at the numbers here. All right, so I've got 6. Well, I could reduce 6 over 4 first. Let's go ahead and do that. 6 over 4 would be 3 over 2. Okay. And then here I've got 2 to the 3/4 power, and I've got x to the 3/4 power. Right? Now, the only thing else I need to deal with is this 4x minus 3. I can put those together. But anyway, 4x minus 3 here. You got 3/4 on the top and 2 on the bottom. So there's more on the bottom than the top. So if you just divide it and just say 2 minus 3/4, and then that would put the 4x minus 3 on the bottom. Or you can think, I'm going to take 4x minus 3 and move it to the bottom. So it'll be 4x minus 3 to the negative 3/4 power. Then when you multiply, you add the exponents, 2 plus negative 3/4. So what is 2 plus negative 3/4? 5/4, okay? So 4x minus 3 to the 5/4. The only thing I did different here is, or else, is I went ahead and just put these two together. So here I've got 2 to the first power times 2 to the 3/4 power. So just add the exponents. What is 1 plus 3/4? 1 plus 3/4. 7/4. 4/4 plus 3/4. And that's how I left the answer. Easy to see there, the outside function is the power of 5. Inside function is secant plus tangent, right? So take care of the outside part first. So multiply times 5. And then subtract 1 from the exponent. Okay, so that's taking care of the power of 5. Now multiply by the inside. The inside, I got to take this, the derivative of secant plus derivative of tangent. So derivative of secant would be what? Secant times tangent. So secant tangent plus the derivative of tangent is what? Secant squared. Okay? Questions about that? Only thing there, like to write the answer in a factored form, you could take a secant out of these two and just write it up here in the front. So I would be fine with that answer on a test, but if you're doing my math lab, they may want it factored. So all you have to do is just take secant out of these two. So you would have 5 secant x, and then you would have secant x plus tangent x to the 4th. And then here it would just leave you with tangent x. Oh, I'm sorry, we can do more. Plus secant x. Okay, yeah, you do definitely want to do this. All right, factor out the secant. Now what do you see here? These two are the same, right? So to multiply them, since they're the same, you just add their exponents. So 4 plus 1, that we can write it as 5 secant x plus tangent x to the 5th power. That would be a good reduced answer there. All right, y'all do this one, okay? So on your paper, okay, got an answer? What's the outside function on that one? Sine, all right? So the derivative of sine, positive cosine. So cosine, and leave what's inside there, 4 cosine z, cosine z, all right? Inside function is 4 cosine z, multiply by the derivative of that. What is the derivative of cosine? Negative sine. So negative 4 sine z. Derivative of z is just 1, so you don't do anything else there. And then I'll just kind of put it together a bit. So this would be negative 4. I'd write negative 4 sine z cosine 4 cosine z. You've got an outside function, which would be what? Power 1/2. Okay. Now the inside function is 1 plus cotangent squared x, but that is also a composition of functions because cotangent squared x, that's not a derivative that we've got, right? So you really got inside, you got 1 plus some, like an x squared, and then you got inside of it cotangent x. So really you have 3 functions here. So the outside would be the 1/2. The inside would be 1 plus this squared, and then inside of it would be cotangent. Okay, so I follow that? So start with the outermost, take the derivative, multiply by the derivative of the next, multiply by the derivative of the next. Okay? Okay, you've got the big outside one is 1/2, right? Inside of that, you got 1 plus cotangent squared. We don't have a derivative for cotangent squared. We have cotangent. So you could say inside there would be 1 plus this squared. Then inside of it would be cotangent. Okay? Let's go through it. We'll see. All right. So derivative. Take care of the outside one first. So multiply by 1/2. Subtract 1 from the exponent. Get 1/2. Okay? Now the derivative of the inside here. Okay? The inside function is, let's say f of x equals 1 plus cotangent squared x. Okay, well, how do I take the derivative of that? Well, it's a sum, so I would say the derivative of the first one, which derivative of 1 is 0, plus derivative of this. Okay, this is really that, right? So I would need to use chain rule to take the derivative of this. So the chain rule, I would say the outside function is 2. So I would say 2 cotangent x to the first power when I subtract 1. Then I've got to multiply by the derivative of the inside function, which is cotangent. What is the derivative of cotangent? Cotangent starts with a c, so it's negative cosecant squared. Yep. So times negative cosecant squared x. So we follow that? So here, when I multiply by the derivative of the inside, I will have that. 2 cotangent, wait a minute. Yeah, that's right. X negative cosecant squared x. Okay, any questions about that before we reduce it?
We have to put the negative cosecant squared x on the other side. We just leave it like that.
You really need to reduce it a little bit. Yeah, just a little. Especially for my math lab. Now on the test, I'm not as picky. I mean, you need to reduce it some, but I would on this one, I would go ahead, just move the negative out in the front. You want to definitely get rid of that negative exponent. So move that to the bottom. So I would say, now we do have 2 over 2 here, right? So you can just go ahead and divide those out. And I go ahead and probably write that as the square root of 1, but you wouldn't have to do that. And then on the top, then we would have cotangent x times cosecant squared x. So that's how I would leave the answer. Okay. Okay. All right, so the derivative, I've got a quotient, right? So I need to start with the bottom. Bottom times derivative of the top. So e to the 3x times 1 minus the top times derivative of the bottom. Now, the derivative of e to the 3x, that has a function inside a function. What is the outside function of e to the 3x? The e is the outside one, right? Inside e is that 3x, right? So what is the derivative of e? E, right? What's the derivative of the 3x? 3, all right? So again, bottom times the derivative of the top minus the top times the derivative of the bottom. Derivative of e to the 3x would be e to the 3x, but then times 3, times the derivative of that 3x, okay? All right, questions about that? So again, that's e would be your big function there, 3x would be inside of it. So e to the 3x, derivative is e to the 3x, times derivative of the inside function is 3. Okay? Common mistake is to leave that 3 off right there. Okay, so follow the rules. Rule breakers do not pass usually. Okay, so you got to follow the rules. Can't be rebellious. All right, square the bottom, and then I just reduce that. So this would be e to the 3x minus, let's write 3x e to the 3x. And then e to the 3x squared would be e to the 6x. I can still reduce that. Factor a e to the 3x out on the top. So I get 1 minus 3x over e to the 6x. Then those e's I can divide there. 3x or 6x minus 3x would be 2x. So 1 minus 3x over e to the 2x would be the derivative, reduced. Okay. It does have chain rule in it. Where will this derivative have chain rule in it at? What part of it will have chain rule? This e to the negative x. Right. Now, this is just e to the x, so that one's good. But this one will have chain rule when we do it. I would divide it first. There's no reason to quotient rule there. You could, but I would do this first. Okay? So that's y. So now derivative then, since it is a sum, it's just derivative of the first plus derivative of the second. So 2/3 e to the x, the derivative of e to the x is just e to the x. So then you're multiplying by a constant, so that's just going to be 2/3 e to the x plus the derivative of e to the negative x, chain rule, derivative of e is e, but then times the derivative of the inside function. The inside function is negative x. What is the derivative of negative x? Negative 1. Let's multiply by negative 1. So y prime would be 2/3 e to the x minus e to the negative x on e. If you want to leave a negative exponent, that's fine for e. Everything else, I probably wouldn't do that. You got 2 inside, right? Is that what? We got 3 total, 2 inside. So the big outside function is sine. Inside, you got sine, but inside that one, then you got e to the x. So you got to start with the outside and just multiply by each one on the inside. So first, derivative of sine is what? Cosine. So I need to say cosine and then leave what's inside there. Sine e to the x. Okay? Multiply times that, the derivative of the inside. What is the derivative of sine e to the x? Well, derivative of sine is cosine. Cosine e to the x. Now multiply by the derivative of the inside of that, which is e to the x. What is the derivative of e to the x? E to the x. And now multiply by e to the x. Okay? Cautious, right? Be cautious there. Any questions? That's probably okay to leave the answer like that. I did. Can't do anything with that, really, reducing it. How many functions total do you have in there? Say 1, 2, 3, 4. Don't you? That's what you meant. Okay. So you've got, if you rewrite it like this, so that fifth thing, that's really over that whole sign, right, is fifth power. So you could rewrite it like this. Right. So your biggest outside function is that fifth power. And then your next one would be sine. Inside it, you have cosine. And then inside cosine, you got 3x. So you really got 4 functions there, right? So start with the outside. The outside would be this power of 5. So my derivative would be, all right, so just multiply by 5, subtract 1 from the exponent. So I would have 5 sine cosine 3x to the 4th power, right? So that would be the outside part, okay, outermost. Next would be sine, right? What is the derivative of sine? Cosine. So I would need to say times cosine of this, which is cosine 3x. All right, so now I've taken care of the power of 5, taken care of sine. Now the times the derivative of the inside. What is the derivative of cosine? Negative sine. So I'm going to put a negative sine and then leave the 3x. And now I've got inside of there a function of 3x. What is the derivative of 3x? 3 times 3. Okay, that's the whole thing multiplied out there. Okay, so multiple chain rules there. All right, so any questions about that part? So let's see if we can reduce it any. I know we can a little bit. You can't do anything with this. The 5 and the 3 we can multiply, and the negative 1 there. So that would give us a negative 15. And then the rest of it you really just leave. So I would have sine cosine 3x the fourth, and then cosine of the cosine of 3x, and then sine 3x. Should be a pretty good answer there. Well, I got radicals in there, right? So I'd go ahead and write those as powers because we've got radicals. That's how we do the derivative, is we do the power of those. So that's, I would change it to that. Okay. And here you really just have two functions, right? You got your power of 1/2. Then you got the inside part. You can in fact take the derivative of that with just one time. So this would be 1/2 times this. Subtract 1 from the exponent. 1/2 minus 1 would be negative 1/2. Now times the derivative of the inside. All right, so the derivative of x is 1 plus the derivative of x to the 1/2, power rule, 1/2 x to the negative 1/2. All right, so that's the thing written out. We just need to kind of fix those negative exponents a little bit, maybe. So this is how I wrote the answer. This isn't bad. I just moved this to the bottom here with the 2. So I did 1 over 2 root x plus root x. Here I did 1 plus 1 over 2 root x, like that. And that's how I left the answer. So I would think that's how my math lab will be wanting that one, if that's a homework problem. What if you're given y equals f of g of x squared, where f and g are differentiable for all real numbers? We want the derivative. Okay, so this is just got some function notation here. Well, you do have a function inside the g one, though, which is what? The x squared. So, using chain rule, I would take the derivative of the outside first, which would be the derivative of f. So I would say f, leave the only inside, that's the outside. Okay. The next innermost would be g, right? So times the derivative of g, and then times the derivative of the inside. The inside of it is the function x squared. What's the derivative of x squared? 2x. There you go. Left it like that. Okay. All right. So the outside function here would be what? Tangent innermost is x e the x, which is just a product. And there's no x squares or any of that in there. So really just two functions is all you're looking at. So what is the derivative of tangent? Secant squared. It would be sad if you had to look that up every time that come up. Aren't you glad that you memorized it now, you know? So, okay. So that's the outside. All right, times the inside. The inside is a product. so we need to use the product rule, right? So the first times derivative of the second, derivative of e to the x is e to the x. So x e to the x plus the second times derivative of the first, derivative of x is 1, e to the x times 1 is e to the x. That answer is okay. If my math lab will not take that, it wants it in a more of a factored form, you could just take e to the x out of that one there, and you could write e to the x, well, let's go ahead and write that first, times x plus 1, and then secant squared x e to the x. Okay? Will be that 1/5 power, right? So let's write it with a 1/5 power. Okay. The derivative then will be, first thing, take care of that 1/5 power. So multiply by 1/5. Subtract 1 from the exponent, so 1/5 minus 1. Negative 4/5, okay? Then times the derivative of the inside, okay? Well, on the inside, you've got a sum, so I just take the derivative of the first plus derivative of the second. Derivative of x the fourth would be 4x cubed. And then plus derivative of cosine 2x. All right, what's the derivative of cosine? Negative sine. So I'm going to go and write plus and then put parentheses. Negative sine 2x, all right, but then I've also got a 2x inside of that one. So now what is the derivative of 2x? 2, right? So multiply by 2. Okay, so that would be that thing written out there. Questions about that? So to write the answer, I would just, let's see, I would write on the bottom 5 and this negative 4/5, move that to the bottom. So I would say 5 times x to the 4th cosine 2x positive 4/5 power. Then on the top I would have the 4x cubed minus 2 sine 2x. Alright, so first to take the derivative, main thing I have there, I have a product, right? So I'm going to have to do the product rule. Now when I do the product rule, derivative of x is not a problem, but here I've got cosine of x squared. So when I take the derivative of cosine x squared, what would the outermost function be on this one? The cosine or the power? Cosine is the outermost, and then the innermost is the x squared. So, got to remember that. Okay, so y prime. First times derivative of the second. Well, derivative of cosine x squared. Derivative of the cosine is negative sine. So negative sine x squared times, so I'm just going to go ahead and put another parentheses there, times the derivative of the inside of that, which derivative of x squared would be 2x. Okay? So that is the first times derivative of the second. Plus second times derivative of the first. Derivative of x is x, so derivative of x is 1, so I get cosine x squared. Okay? So I could probably write that before I take the second derivative. So let's write it as cosine x squared minus 2x squared sine x squared. Okay. Now to do the second derivative, I just take the derivative of the first derivative, right? So let's do it again. All right, so here I've got a difference. So separately, I take the derivative of this one minus derivative of this one. So first one, Again, we have this cosine x squared, right? So the derivative of that, the outside function is cosine, inside is x squared. So derivative of cosine is negative sine, and that'll be x squared, leave what's on the inside, times the derivative of the inside, derivative of x squared is 2x. So that times 2x, okay, minus the derivative of this. Well, here I've got a product again, all right? And I can just take the 2 out in front. I'm going to put the 2 out in the front. Okay? So x squared and sine x squared. So the first times derivative of the second. So I have x squared times, all right, sine x to the second. The outside function is sine. The inside function is x squared. So derivative of sine would be cosine times the derivative of the inside, which is 2x. All right, so that is the first times derivative of the second, plus the second times derivative of the first. Derivative of x squared is 2x, so 2x sine x squared. Follow the rules, okay? All right, so now to reduce that a little bit, let's see. Let's just go ahead and get rid of those parentheses first. All right, so here I got to multiply negative 2 to both of these. So this would be negative 4x cubed cosine x squared, and this would be minus 4x sine x squared. Okay, so I could put this term and this term together because they both have x and sine squared x in them. So final answer for the second derivative would be negative 6x sine squared x minus 4x cubed cosine x squared. Okay, so second derivative. First, I would write this as x squared plus 2 to the 1/2 power. All right, we're going to find the first derivative first, okay? So that one, pretty straightforward. The outside function is the power of 1/2. Inside function is x squared plus 2. So I would say 1/2 x squared plus 2, and then subtract 1 from 1/2. That'll be negative 1/2. Times derivative of the inside, derivative of x squared plus 2 would be 2x. All right, so that first derivative, we can reduce that a bit. The 2's will cancel, so you would really just have x over x squared plus 2 to the 1/2 power. Okay, any questions up to that point? Second derivative, find the derivative of that one. Okay, so second derivative. We got a quotient. Follow the quotient rule. All right, so we start with the bottom. We say the bottom times derivative of the top minus the top times derivative of the bottom. Okay. Well, the bottom is x squared plus 2 to the 1/2, which was the problem, right? We've already found that derivative. What was this derivative? It was this, all right? I'm going to put that in the place of the derivative of x squared plus 2 to the 1/2 power. So here I would have x over x squared plus 2 to the 1/2 power, okay? So again, bottom times derivative of the top minus the top times derivative of the bottom, which is actually that thing right there. Okay? Over the bottom squared. So if I square that That means I multiply 2 times a half, so I just get x squared plus 2 on the bottom. Okay? Now, we do need to reduce that a bit. So rather than rewriting all this again. All right, so just notice on the bottom, 1/2 times 2, that's just going to leave that x squared plus 2 on the bottom. When I square the bottom, okay? All right, so my main issue here is I have a fraction inside a fraction. And that's a no-no, right? So how do I get rid of a fraction inside a fraction? Easiest way is to what? Anybody? Multiply the top and bottom by the least common denominator of all the fractions. The only denominator I've got is x squared plus 2 to the 1/2 power. So let's multiply the top and bottom by that. And that should fix this to where we don't have any fractions inside fractions there. So it's like multiplying by this over 1. When I multiply by that over itself, I'm just multiplying by 1. So it doesn't change the value of it. Alright, so equals. Alright, this times the first one. So I'm distributing this to both of these on the top. This times the first one, if I have x squared plus 2 to the 1/2 times x squared plus 2 to the 1/2, I can add their exponents. I just get x squared plus 2. Okay? Minus. Here, when I multiply this times this one, that x squared plus 2 to the 1/2 will cancel with that one, which that's the purpose of doing this. I still have x times x squared, and that this x here is like x over 1, right? So I do multiply the top one. So that would be minus x squared over the bottom. I've got x squared plus 2 to the first power times x squared plus 2 to the 1/2 power. So I can add their exponents. I get x squared plus 2 to the 3/2 power. X squared minus x squared is 0, so my final answer for the second derivative is 2 over x squared plus 2 to the 3/2 power. Alright. A little bit of algebra there, but if you practice it, you will be able to do it. Alright, that is chain rule. Chain rule is very important. You use it from now on in calculus.